Hey everyone, in this video we're going to go through the 2016 exam 1, just looking at questions 2 and 8. Let's get into it. So first of all, when we're finding the derivative, so remember your early questions are usually just calculus questions, so take note of, well, this is okay, this domain is just giving us the implied domain for this function. Now, if we're finding the derivative, just remember we can rewrite this as 1 minus 2x to the power of a half. Now we just use the chain rule. So we're going to let u equal 1 minus 2x. So du dx is equal to negative 2. And when we let u equal 1 minus 2x, we get y equals u to the power of a half. And then dy du is equal to 1/2 u, and then we just reduce that power by 1. All right, so our derivative is equal to, just using the chain rule, we have negative 2 times 1/2 of u, which is 1 minus 2x, and then negative 1/2, and we should probably tidy that up a little bit. So negative 2 times 1/2 is negative 1. And then we've got this negative power and a half, so we can do 1 over the square root of 1 minus 2x. And just because I've got my pen here, I'm going to just tidy that up, because we'd probably just put the minus up here. All right, so negative 1 over the square root of 1 minus 2x. All right, part B, find the angle theta from the positive direction of the x-axis to the tangent to the graph of f at x equals negative 1, measured in the anti-clockwise direction. All right, so when we're thinking of the angle, I'm just looking at what we've got here. From the positive direction of the tangent to the graph of f at x equals negative 1. All right, so what we're going to do is look at the gradient of the tangent at x equals negative 1. So we've got our gradient function from the previous question. So let's just substitute in x equals negative 1. So we're going to have the square root of 1 minus 2 times negative 1. Now, I probably wouldn't do all that substitution. I would, I'm wasting time by doing it in multiple steps, but that's okay, because this is a video, not the actual exam. So in your exam, I probably wouldn't write this. Negative 2 times negative 1 is positive 2, so it's the square root of 3. Now, what this is the gradient of the tangent at x equals negative 1. Now, what we're doing is finding the angle from the positive direction of the x-axis to the tangent of the graph. All right, so what we've got here, our square root graph, let's just have a look at what that actually looks like. So our square root graph starts, so this one here, what have we got? We've got a few transformations. Kind of just want to see, it's been dilated, but that's okay. It's been reflected. So our basic square root graph kind of goes like that, but this one's been reflected and shifted up 1. So let me just do that all in one go. So it's kind of like that. Let's take that off. So at x equals negative 1, so here's negative 1, we've got a point. So we've got this tangent line here, and what's the question? All right, I did have to delete a little bit there, so let me just pick up where I was. So we've got this tangent line, and the question is asking for the angle from the positive direction. Let me just get my pen back. From the positive direction of the x-axis. So here's the positive direction of the x-axis. So we're actually looking for this angle here, measured in an anti-clockwise direction. Yeah, that doesn't really matter. All right, but the key thing to look for is this right angle triangle here. So I'm going to redraw that over here, and we're just going to find theta first of all. Now, when we're dealing with an angle, like a question that asks for an angle formed with a straight line, like we do here with a tangent and the x-axis, we're going to form a right angle triangle. We're going to use either rise over run or the gradient of the tangent, which is what we've done here, which we've got -1 over root 3. So this part here. So the negative is because it's a negative gradient. All right, we can see it's sloping down. So our rise is 1 and our run is 3. Oh, I shouldn't say our rise. Our rise, we're going down 1, but the length has to be positive. So it's got to be a positive 1 and root 3. So basically, tan theta, which is equal to opposite over adjacent, remember back to SOHCAHTOA, is 1 over root 3. So knowing your exact values, that's 30 degrees. But that's that angle in here. So if you got this far, you'd probably get 1 mark. You do have to go on and actually answer the question correctly. So we want that other angle. And obviously it's going to be a straight angle minus the 30 degrees. So that's 150. Now, this is on exam 1. I kind of feel like you would only get your exact values of 30, 45 or 60 in a situation like this. So if you knew it was a negative slope and we could see it was an obtuse angle, you could do 180 minus 30 or 180 minus 45 or 180 minus 60 if you didn't know which one it was. And just hope for the best that you guessed the right one. You've got a 1 in 3 chance of guessing correctly. Let x be a continuous random variable with probability density function, blah, blah, blah. Part of the graph of f is shown below. The graph has a turning point at 1 on e. Show by differentiation that blah, blah, blah is an antiderivative of blah, blah, blah. All right, so show by differentiation. All right, so we're going to differentiate this because it's a show that question. And when I see something like this, it's just screaming integration by recognition to me. And I'm wondering if we're going to have to use that later on, I would say. Anyway, I feel like I've done this question before, now that I just saw that last part. All right, let's do it again. So we've got, oh, sorry, we're not doing the antiderivative. Sorry, guys, let's find the derivative. So we want d dx of xk on k squared times k log e x minus 1. Now we can use the product rule. We can also expand the bracket if we wanted to. I'm just thinking whether that actually makes it any easier for us. I don't think so. All right, so let's let u equal e to the power of k on k squared. Now, the k is just a constant, a number, so you can, if it helps, you can think of it as 1 on k squared times x on k. So du dx, we multiply the front by k, or the coefficient, sorry, front, and then we've got k minus 1 as our power, and then keep scrolling down. I'm like, I hope they've given me more space. 1 on k x k minus 1. All right, and then I'm going to let v equal function in the bracket. So k times log e x minus 1. So dv dx is equal to, the k is going to be multiplying that, so it's just k on x. So using your chain rule, so d dx is equal to 1 on k, not chain rule, sorry, product rule. Oh my gosh, what am I talking about? 1 on k x k minus 1. So du dx times v, so k log e x minus 1. I'm just going to quickly check the formula sheet to make sure I've got that right. And I did it around the wrong way, but that's okay because we do add them together, but let me just be consistent with the formula sheet. So I did du dx times v. It actually doesn't matter because you're adding them. All right, we've got to do u. So I'm just doing the product rule times dv dx plus v times du dx. Oh, my nose is dripping. Sorry, let me just fix this up. Okay, look, x minus 1, and we're multiplying that by, so we're multiplying, so put it in brackets, 1 on k, x, k minus 1. Alright, so let's just tidy this up. So, we can, so put this on as 1, so the k, so we're going to have 1k down the bottom, and then this is k to the power of 1, so we can rewrite this as x to the power of k minus 1. Alright, and I'm going to just write this and then do my cancelling. Over k, and the x, k minus 1. All right, we do have the same denominator because remember we're is an antiderivative. So we're aiming to get this. Alright, so you can see we've got the same denominator. Sorry, I had to pause to wipe my nose. So let's just put everything up at the top, minus 1. I'm going to expand this bracket because what I've put around the the rectangle around is what we want, and currently it's not. So clearly that k cancels out or something. Alright, so we've got k x k minus 1 log x minus x k minus 1. So I've just multiplied this by both terms inside that bracket. Alright, oh, so they cancel out now, and then that k cancels out with that k. And then that's what we wanted, yay, so exciting. Alright, lots of working out there, which is, whoops, I've got my little e there, that's okay, I wouldn't probably be penalised for that. Alright, I'm not sure where I left off, so let's just recap this question here. So whenever you've got to show that question where you've got the relationship between a derivative and the antiderivative, it's an integration by recognition question. So when we move on to part B, I can see, yep, it's an integration by recognition question because we're referring to a continuous probability, and if we're finding the probability of anything, we're finding the area under a curve, and that means we're using a definite integral, which is antidifferentiation. So what we want is the definite integral going from, so x is greater than 1 on e, so 1 on e, and our upper terminal is 1. So that was just given to us at the very start. All right, so there's our function, negative 4x log base e of x from 0 to 1. So we're using that function again. I'm going to write it here. All right, and it's important to write it instead of just writing f of x, because it's good to see what you actually want. Now, what do we have? Okay, so we have, and it was in our previous question, and it's still on the screen, which is awesome, x to the k minus 1 log base e of x dx. That's what we have. And we know that the antiderivative to that is equal to this. All right. It's told us in the question it's an antiderivative. So, did I write it down yet? I've written it down so I don't have to write it again. So we have x on k over k squared, k log base e of x minus 1. All right, so I want my left-hand side to end up being what I want, all right, that on that very top line. I can see it kind of looks like it. All right, so at this point in time, I'm thinking, well, my power here is 1, and so that means k must equal 2. All right, so wherever I see k, I'm going to put in 2. And I've also got this -4, which isn't here. So I can put it in just by multiplying both sides by -4. So I'm going to put that -4 in. Now, you can put it before your integral sign or after, but I'm going to put it after. Doesn't actually make any difference. Hopefully you know that. But I do have to, let me just put that so we don't get confused. I do have to, what do I have to do? Multiply the other side by -4 as well. So I'm going to do that in big brackets just because I've got so much going on here. And remember, k is equal to 2. So when I substitute that in, I'm going to have x squared over 4 times 2 log base e of x minus 1. So I've just multiplied that side by both sides by -4. And because k is equal to 2, we've got that as well. All right. Ideally should tidy that up because there's way too much there that can be cancelled. So this 4 and this 4 cancel out, but that -4 is also, no, it's not. It's all good. No, they can cancel out. And then I've got -x squared. And then the 2, so that is multiplying all of this, x minus 1. All right, and it's probably okay to leave it like that. I can expand it. So 2x squared log base e of x, plus x squared. And I'd probably just leave it like that. Should be fine. Now, I've just realized I found the antiderivative, but I didn't do the definite integral, and I'm like, where am I supposed to do this? Where's the space on this page to do my definite integral? So, where am I going to do it? Let's do it over here. All right, and I'm hoping, because I was looking at the solutions, that's how I remembered I didn't have the definite integral, but let's just keep going with this. Now I'm not confident with my antiderivative. God, what's that going to be? Well, that's good. So when x is 1, this whole thing becomes 0, so that's good. So that's just going to be 1. And then when I substitute in 1 on e, so that's e to the e to the, okay, so log base e of e is 1, but 1 on e gives you -1. So it's going to be -1 times -2 is +2. So plus 2, sorry about the dog, 1 on e squared plus x squared. So 1 on e squared again. I feel like do I need space down the bottom here? Let's do it down here. All right, so let's continue that. 2, let me just tidy it up, e squared plus 1 on e squared. So 1 plus 3 on e squared. And I'm pretty sure that's the answer. Let me just have a quick look. 1 minus 3 on e squared. I had a plus there. Oh my gosh, that is so annoying. All right, I'm going to figure out where I went wrong. Just give me 1 sec. All right, I've just rewritten it here. So you can see there's my definite integral, exactly the same as before. I've clearly made a mistake with my negatives just because I was probably trying to do most of it in my head. So now you can see I've done the substitution. So let's do everything with a bit more care. All right, so when you've got a log of 1, all right, so that's just 0. All right, will always be 0 no matter what your base is. So that's going to be 0 plus 1. All right, so that's just going to end up with a 1. All right, just making sure that's correct. All right, then moving on to the other one. So we've got 1 minus. Then we've got negative 2 times 1 on e squared. So that's going to be negative 2 on e squared. Then log base e of 1 on e. All right, so let's just, so that 1 on e is the same as e to the negative 1 plus 1 on e squared. So just write that. All right, tidying it up a little bit. So, runny nose. Okay. So the log base e to e, that's 1. So we're just left with negative 1. So times negative 1. And then we've got plus 1 on e squared. All right. I'm going to keep that 1 out the front until I've tidied up everything inside the bracket. So we've got a negative times a negative, which gives us a positive. So we've got 2. Oh, beautiful. Here we go. That's going to give us a minus. Beautiful. Which is very frustrating in an exam. So an example of where you just need to take your time, because you saw I try to squish everything. I try to do a lot of the stuff in my head. If you do run out of space on a page, you just find a blank page or another space and you say, my answer is on page whatever, wherever it is. Usually they do leave a bit of space if they think there should be more work. Well, see how this blank page is down here. Actually, do I have the exam open? Do I have it open here? No. Just the solutions. All right, anyway, let's move on to the next one because that was a long time. Hence, explain whether the median of x is greater than or less than 1 on e, given that e is greater than 5 on 2. All right, so hence explain whether the median of x is greater than or less than 1 on e. I did have to do this question not on the spot just because there was a bit of thinking involved as to what to do. So we're explaining whether the median of x is greater than or less than 1 over e, given that e is greater than 5 on 2. So you do have to show some calculation, and we're using the previous question, or previous answer, I should say. So you can see I've got the probability of x is greater than 1 on e is equal to 1 minus e squared. Now in the question it's saying that e is greater than 5 on 2, so we've got this. So I've just substituted that in for e to see what we get. So we've got, we do end up, you can see that substitution there, we end up with 13 on 25. So that means, like if we think about the median, which is a halfway point, half of 25 is 12.5 over 25. So this is greater. So therefore, the median is greater than 1 on e. Now, when I was looking at the solutions, so this I think is the very last question. So you can see that 87% of students didn't get any marks for this question, and it's highly likely they left it. So this is an example of a question where you probably would think, is it worth my time answering it? Especially because it depends on the previous answer, which, you know, part 8A is an integration by recognition question. I don't think an overly difficult one, but you can see there 17% of students got full marks for it. And then we've got 12% of students got full marks for the part B part 1, and then 7% of students got full marks for B part 2. So a question like question 8 is your separator. It's the one that really, you know, your top students, it's kind of separating them. So we can see, you know, 17% of students, and then we're going down as low as 7% of students, which is very, very low. All right, but anyway, still good arithmetic and good understanding, use of, you know, negatives and fractions, and maybe what not to do. Don't rush things, because if you forget a negative, you get it wrong. Anyway,